Hello friends, welcome back to my YouTube channel Learner AK. Friends, today we discuss about a very important topics of MSc Physics, PG SEM 3rd. This is very important topics friends for final exam purpose. This is Yukawa interaction, Meson theory of nuclear force. This is very important topics friends. Let's discuss about now. To account for a nuclear binding energy of 8.6 MeV per nucleon, strong interaction characterized by a coupling constant of the order of unity is needed. H. Yukawa, 1935, pictured the short-range internucleon force in terms of field quantum pi meson of the nuclear field. The pi meson were discovered in cosmic ray radiation. When a meson is sent from one nucleon to another as it must for the propagation of the nuclear force, the creation of the meson violates energy conservation law by an amount del E of the order of meson raised to mass m naught pi. Del E is equal to m naught pi c square. The uncertainty relation del E del t is equal to h cut finds the time limit del t for which such a violation of energy conservation law can rest. If we assume that the meson travels with the speed of light, then the maximum distance it can be cover is r naught is equal to c del t is equal to c into h cut by del E. C into h by m naught pi c square is equal to h cut by m naught pi c. M naught pi is equal to h squared by r naught c is equal to 1.055 into 10 to the power minus 34 by 1.4 into 10 to the power minus 15 m into 3 into 10 to the power 8 meter per second. Therefore, m is equal to 9.11 into 10 to the power minus 31 kg. Hence, m naught pi 270 me. This theoretical value of pi meson's mass is in well agreement with its experimental value 223 me measured. Experimentally in cosmic ray showers, their pi mesons are rearranged regarded as quanta for the nuclear field. Electromagnetic and gravitational forces have infinite range due to zero rest mass of their field quanta, while nuclear force is extremely short-ranged. Yukawa potential is responsible for the nuclear forces. Relativistic energy is equal to p square plus m naught square c4 half is equal to p square plus c square plus m naught square c4. This is equation 1, friends. In terms of quantum mechanical operator form, minus h cut square del square by del t square is equal to minus h cut square delta square c square plus m naught square c to the power 4. This is equation 2, friends. Introducing a function phi r vector t and dividing expression 2 by h quota square c square del square phi minus 1 by c square del square phi by del t square minus m naught square c power c square by h quota square phi is equal to 0. This is equation 3, friends. The function has the significance of the potential and it can be regarded as field variable. This is known as the Kelvin-Gordon equation for a spin zero relativistic particle. If m naught is equal to 0, then equation 3 becomes del square phi minus 1 by c square del square phi del t square is equal to 0. This is equation 4, friends. This is Maxwell equation from which electromagnetic field is derived. The simplest type of electromagnetic EM field is the electrostatic field for del phi by del t is equal to 0 and then delta square phi is equal to 0. This is equation 5. It is Laplace's equation and the well-known solution for the potential is phi is equal to E by R. For pi mesons, equation 3 may be written as delta square phi 1 by c square into del square phi del t square minus m naught square pi c square by h cut square phi is equal to 0. This is equation 6, friends. The time-independent parts can be obtained by substituting phi is equal to phi r e to the power I omega t. This is equation 7. In equation 6 and getting del phi by del t is equal to 0, then delta square phi minus m naught pi c square by h square phi is equal to 0, or delta square phi minus k square phi is equal to 0. This is equation 8, friends, where k is equal to m naught pi c square by h is equal to 1 by r naught. Equation 8 is valid for a Meson field and it is analog of Laplace's equation. In presence of changing, if you need Poisson's equations analog, del square phi is equal to 4 pi e rho, where E is equal to electric charge, rho is equal to electric density, and then delta square minus k square phi is equal to 4 pi g rho. G is the effective nucleonic charge or coupling constants measure the strength of interaction between the nucleon and the Meson field. G rho can be replaced by G delta r. Delta r is equal to 1 8, r is equal to 0, and delta r is equal to 0 8 finite r. Then delta square minus k square phi is equal to 4 pi g del r. This is equation 9. The solution of equations 8 and equation 9 can be obtained by substituting phi is equal to minus g e to the power minus k r by r. In the Meson field, the interaction potential Vr of the nucleon of charge G with the Meson field should be Vr is equal to g phi minus g square e to the power minus r by r naught by r. This is equation 10, where r is equal to position vector. This is the required Yukawa potential and it is represented graphically as, friends, now you can see graph Vr is equal to minus g square e by r minus r by r naught. Feynman diagrams. First, pp interaction. This is the pp interaction diagram, friends, and then second, nn interaction, and then third, np interaction. You can see the figure, friends, and four, pn interaction. Now figure 1 to 4 represent on pion exchange. A number. In Meson's theory, the nuclear particle does not change charge, and hence Nn, Np and Pep forces are equal according to the theory. B. The theory does not explain the exchange nature nuclear forces, which can be established from high energy scattering experiment. The theory is also unable to explain the spin dependent and the presence of the non-central force. One pion exchange potential was found to fit experimental data for internucleon distances to fm. The interaction potential given like two large dimensionless coupling constants minus g square by h c, and this suggests that more than one meson is transformed simultaneously between two nucleons. Thank you, friends. We meet in next video. If you are new in my YouTube channel, please subscribe my YouTube channel and please support me. Thank you, friends.